Hello, welcome to the Calm Universe channel. Here the stories are slow, long, and calm. Before we begin, take this moment while you're still awake to subscribe and like this video. In a few minutes, your mind will be traveling through stars, planets, and the sounds of distant rain. Now simply settle in, close your eyes, breathe slowly, and let us begin tonight's quiet story. Good night. In this quiet story, we will explore what will slowly happen on the day the sun will die. Not as a dramatic event, but as a patient transformation that will take place over unimaginable spans of time. Everything you will hear is real, based on the steady knowledge of science and the silent rhythm of the universe. The sun that warms the Earth today has existed for about half of its long life. It burns quietly, turning hydrogen into helium, releasing energy that travels across empty space until it reaches our small planet. This light is steady, dependable, and slow. Each photon that touches your skin has traveled for about 8 minutes through the dark, moving at the same pace as billions of others that have done so since the beginning of life. When we speak of the sun's death, we do not mean a sudden disappearance or an explosion that could be seen in an instant. We mean a sequence of slow and inevitable changes that unfold over billions of years. It is a process that follows a rhythm older than all living things, older than every story, older than memory itself. The sun's story is not a tragedy. It is a cycle that every star experiences. From the birth of light to the quiet return to darkness, it is the same calm rhythm that governs the universe. Everything that exists moves from energy to stillness, from heat to balance, from brightness to silence. As you listen, imagine this change not as something to fear, but as something to understand. The sun will not fight its destiny. It will simply follow the laws of nature that have guided it since the beginning. Those same laws hold the Earth in its orbit, shape the stars, and maintain the quiet order of everything that is. In this moment, the sun continues to shine as it always has, steady and unchanged, spreading warmth across the solar system. Its story continues at a pace that is almost too slow to measure. We live within its gentle balance, and tonight we will follow its path forward, step by step, until the end, and beyond the end, into the silence that comes after. The sun as it is now. At the center of the solar system, the sun remains constant. It is a sphere of glowing gas, held together by gravity and balanced by the steady outward pressure of its own heat. It is neither loud nor sudden. It has been shining for about 4.5 billion years, and it will continue to do so for about the same length of time still to come. Every second, deep in its core, countless hydrogen atoms combine to form helium. This process, called nuclear fusion, releases energy that moves outward slowly, layer by layer, until it reaches the surface and escapes as light. From the Earth, this process seems immediate, but the light that reaches us today began its journey from the sun's core more than 100,000 years ago. Inside, the energy moves in a slow and patient dance, scattering from one particle to another, changing direction millions of times before finally leaving the sun, as the warm light that falls gently on oceans, mountains, and skin. The sun's surface, called the photosphere, glows at a temperature of about 5,500 degrees Celsius. It is neither still nor violent, a constant motion of rising and falling gases like a vast and endless tide. Around it extends the corona, a faint outer layer that can be seen only during a total solar eclipse. Beyond that lies the emptiness of space, quiet and without air, where the sun's light continues outward to touch the planets one by one. The sun's gravity holds the entire solar system together. Every planet, asteroid and comet moves in response to its pull. The Earth orbits at a distance of about 150 million kilometers, a space so vast that even light takes 8 minutes to cross it. In this stillness, the sun gives more than energy. It gives rhythm, the pattern of day and night, the seasons, the slow alternation of warmth and cold. The sun appears eternal to us because our lives are so brief. To the sun, a human lifetime is less than a blink. Its changes happen in spans so large that they are invisible to our senses. Its heartbeat, measured in millions of years, is steady and unhurried. This is the sun as it is now, balanced, mature, and quietly alive in the endless rhythm of space. The slow drift of time. Time on the scale of stars does not move as it does for us. It flows in vast intervals, passing through ages rather than moments. The sun, which seems constant, is slowly changing with each passing second, though those changes are too small to be noticed. Over billions of years, the balance of energy within its core will shift. The hydrogen that fuels it will decrease, while the helium created from fusion will continue to accumulate. The process is quiet, patient, and precise, unfolding at a pace so slow that even the Earth's continents, drifting over the surface of the planet, seem fast by comparison. During this long drift of time, the sun will grow slightly brighter. Its warmth will increase very gradually, and the Earth will feel this change not as sudden heat, but as a slow alteration in climate that takes place over hundreds of millions of years. The oceans will slowly evaporate into the atmosphere, then into space. The air will thin, and the surface will dry into silence. These are not events that happen within generations, but over spans that stretch beyond imagination. The moon will move farther away, retreating at the rate of a few centimeters each year. Its gravitational pull will weaken, and the tides will lose their familiar rhythm. The nights will become longer, the stars will seem more still, and the Earth's rotation will continue to slow. The energy that once shaped the planet's surface will settle into quiet equilibrium. Through all of this, the sun will remain calm. It will not flicker or fail. It will continue its steady work of fusion, transforming hydrogen into helium, sustaining the delicate balance that has lasted since its birth. From afar, a distant observer would see only stability, unaware of the immense processes taking place within. In this part of its life, the solar system becomes older, heavier, and quieter. Planets continue their orbits, asteroids drift through cold space, and light continues to travel outward at its constant pace. Each photon that leaves the sun begins a journey that will last until it meets dust, a rock or another world, or until it fades into the background of the universe itself. Time does not rush, it does not stop, it continues to stretch, long and smooth, shaping the destiny of everything it touches. The slow drift of time carries the sun toward its next phase, one so gradual that it cannot be sensed, only described. When balance begins to shift, inside the core of the sun, the transformation of hydrogen into helium continues with quiet precision. Each reaction releases a small amount of energy, and over billions of years, that energy keeps the sun in balance. But as the hydrogen becomes less abundant, the helium ash at the center begins to build. The core grows heavier, denser, and slightly hotter. The sun adjusts itself to this change, as it always has, without haste or resistance. This adjustment is not sudden. It unfolds slowly, across spans of time far beyond the measure of human understanding. The sun's outer layers expand by tiny fractions, responding to the increased pressure of the heating core. It becomes, step by step, a little brighter. To the Earth, this change is invisible at first. The daylight seems the same, the warmth familiar, but across hundreds of millions of years, the difference accumulates. The calm equilibrium begins to shift. The sun's balance is a delicate conversation between gravity pulling inward and energy pushing outward. For now, they remain in harmony, but the harmony is changing its tone. The core's density increases as hydrogen runs out, forcing the inner regions to contract slightly. The contraction raises the temperature even more, speeding up the reactions that remain. This quiet acceleration marks the beginning of the sun's transformation into a different kind of star. On the planets, nothing happens suddenly. The Earth continues its orbit. The gas giants remain distant and slow. But beneath this stillness, the physics of the sun is writing a new story. The outer layers will soon respond more noticeably to the shifts within. They will begin to expand and cool, spreading light and heat differently through the solar system. There will be no single moment to define this change, no event that divides before and after. It is a continuous process, the sun slowly leaving one phase of life and entering another. Like a tide that rises by imperceptible degrees, the balance alters so quietly that only time itself bears witness. In this transition, gravity still holds, energy still flows, and the laws of nature remain constant. Nothing is broken, nothing ends. The balance simply becomes new again, taking on a different form as the sun prepares for the next long stage of its journey through time. The expansion into the red giant. Over the course of billions of years, the slow shift within the sun will continue. The core, now rich in helium, will contract further under its own gravity. The surrounding layers will respond by expanding outward, and the sun will grow larger than it has ever been. Its light will soften in color, changing from white to a deep, steady red. The transformation into a red giant will not happen in a moment of eruption, but in a long, quiet sequence that unfolds across ages. As the sun swells, its outer surface will cool, though the core will become far hotter. The energy will move outward through layers that stretch into space, forming an enormous sphere many times wider than its original size. The orbit of Mercury will no longer exist. The small planet will be absorbed into the sun's glowing body. Venus will follow, and the heat reaching the Earth will grow too strong for its atmosphere to survive. Yet each of these changes will occur slowly, in silence, over millions upon millions of years. To an observer far away, the red giant sun will seem majestic and still. Its light will fill space with a calm, diffuse glow. The edges of its surface will appear soft, fading gradually into the dark around it. Inside, helium will begin to fuse into heavier elements such as carbon and oxygen, and each new stage will bring more light, more expansion, more quiet movement outward. The Earth, long before this time, will already be lifeless. Its seas will have turned to vapor, its rocks will have fractured from the heat, and the air will be gone. Yet from a distant planet or drifting piece of dust, the scene will not appear violent. The red giant will shine peacefully, slowly radiating the last of its deep energy into the surrounding void. In this state, the sun will reach the height of its size and brightness. The balance that has held for billions of years will have found a new shape. What once was compact will now be diffuse. What once was steady will now be broad and soft. The red giant will remain for a long time, holding its new form in gentle suspension before beginning the next transformation, one that will lead not to collapse, but to release. The fading of the planetary system. The fading of the planetary system will not come with sound or light or any mark that separates one era from another. It will happen quietly, through the same slow persistence that has shaped the universe from its beginning. When the sun becomes a red giant, its great expansion will send its warmth farther than before. But that warmth will no longer be the gentle light that nurtures life. It will be diffuse, vast, and faintly red, stretching across space in soft waves. The sun's outer layers will grow thinner, drifting outward, forming a halo of gas that spreads through the solar system, light as mist and wide as distance itself. The innermost worlds will have already disappeared. Mercury will have been swallowed completely, its metals absorbed into the sun's envelope. Venus, once bright in the morning sky, will be gone as well, drawn into the growing sphere of the red giant. The Earth will no longer be blue or alive. Long before the sun's greatest expansion, its increasing brightness will have stripped the planet of its oceans and air. The seas will have boiled away, the clouds will have vanished, and the winds will have ceased. What remains will be dry, fractured stone, glowing faintly beneath a sky of dust and silence. Mountains will crumble slowly as heat expands the minerals of their cores, and the surface will become smooth and still. From far away, this transformation will not seem violent. To an observer beyond the outer planets, the red giant sun will look calm, immense and slow. Its edges will blur into the blackness of space, like a fading memory of what once was. Around it, the remaining planets will continue to orbit, but their paths will change slightly with time. Jupiter will drift outward as the sun's mass decreases. Saturn will move with it, keeping its rings, though they will dim as the sunlight weakens. The ice giants Uranus and Neptune will remain at great distances, circling through darkness. Their cold atmospheres will reflect the red light faintly, as if the memory of the old sun lingers on their surfaces. The asteroid belt will lose its balance. Each rock will move along a slightly altered path, some colliding slowly, others drifting into the vast emptiness between planets. The delicate gravitational rhythm that once guided their movement will loosen. Space will become filled with fragments, not colliding but slowly separating, each piece following its own quiet course. The sun's outer layers, expanding and cooling, will begin to escape into this space, forming a wide and faint shell of gas. It will glow for a time, illuminated by the sun's remaining heat, creating what astronomers call a planetary nebula. But this glow will fade, slowly, evenly, like the breath of something falling asleep. Within the outer reaches of the system, the Oort cloud, that great sphere of icy bodies surrounding everything, will begin to dissolve. Many of its comets will drift away, pulled by passing stars or the subtle currents of galactic gravity. Others will fall inward toward the dying sun, but their journeys will take millions of years. The solar system will no longer be a compact family of worlds orbiting a single star. It will be a wide field of scattered objects, each slowly moving through the dim light of a fading center. The fading of the planetary system will not mean its disappearance. The planets will still exist, though their orbits will stretch wider. The sun's grip will loosen as its outer layers escape into space. Light will continue to flow outward, but the energy will weaken as distance grows. The warmth that once nourished Earth will spread across the emptiness, too thin to touch or to hold. Each world will become colder, their surfaces frozen in silence. In this long decline, there is no rush, no event to mark an end. Every motion will continue as it always has, only slower. The rotation of planets will persist. Their shadows will still move across the faint light of the sun, but there will be no watchers to see it, no living things to record the quiet transformation. The universe will keep its pace, indifferent and exact, letting one system fade as another begins elsewhere. When the sun's expansion reaches its limit, the outer layers will detach completely. The red giant will shed itself in slow motion, leaving behind a luminous shell that drifts away in silence. The core that remains will shrink and brighten, small and white against the dark. The solar system will no longer be what it was, not a place of warmth and motion, but a faint memory of light, a pattern of orbits around something that is no longer a star, but a remnant. This is how fading happens in the universe. Not through sudden absence, but through the long and steady dispersal of energy. Gravity weakens, light spreads thin, matter cools, and space grows quiet again. Everything that once moved together becomes separated by distance and time. What was once full becomes empty. What was bright becomes dim. The planetary system will not vanish all at once. It will simply drift away, atom by atom, into the wider calm of space. In the end, nothing will be lost, only rearranged. The atoms that formed planets and air and light will continue their journey through the galaxy, carried by the faint wind of the sun's last breath. They will mix with dust from other stars, waiting, patient, until gravity gathers them again. Somewhere, sometime far beyond measure, new light will begin to shine from that dust. And just as slowly it will start the rhythm again, the quiet creation of another sun and another world beneath its warmth. The quiet birth of the white dwarf. The quiet birth of the white dwarf will begin when the sun's outer layers have drifted too far to remain bound by gravity. Over millions of years, the red giant will release itself into space, leaving behind a small, dense core that continues to shine. What remains will be no larger than the Earth, yet it will contain most of the sun's mass. It will be a white dwarf, a faint and steady point of light surrounded by the ghostly shell of what once was a star. This transformation will not happen with sound or violence. It will occur in silence as the last currents of heat flow outward, stabilizing into stillness. The white dwarf will glow not because it burns new fuel, but because it retains the heat of its former life. It will no longer fuse atoms in its core. The energy will be a memory, radiating slowly into the darkness. Its light will be soft, pale, and constant, fading gradually over trillions of years. From a distance, this small remnant will seem quiet and lonely, yet its presence will be precise and ordered. The white dwarf will have an immense density. A single teaspoon of its matter would weigh as much as a mountain. Its gravity will be strong but contained, holding tightly to what remains of the solar system. The outer planets, now drifting in wider orbits, will continue to circle the white dwarf, their path stable but slow. The space between them will grow colder with each passing age. The light of the white dwarf will cast no warmth upon the worlds that remain. The once familiar glow of day will be gone, replaced by a faint shimmer, like the reflection of starlight on ice. The planets will not melt or burn. They will simply exist in shadow, silent and unchanged. The rings of Saturn will freeze solid. The gases of Neptune will settle into still layers, unmoving in the absence of wind. Even the smallest fragments of dust will fall into quiet orbits, drifting with no destination. Around the white dwarf, the remnants of the sun's expelled outer layers will form a thin nebula. It will be faint and colored by the light of the dying star, soft pinks, pale blues, and traces of green. This shell of gas will expand steadily, growing more transparent as it cools. Eventually it will disappear, merging with the interstellar medium, leaving only the white dwarf to mark the sun's existence. The white dwarf will continue to cool, but the process will take time beyond imagination. Each century will bring only the smallest change. Each million years will pass unnoticed in its calm, steady fading. Over time, the atoms within it will settle into perfect order. Heat will become balance. Light will become memory. The white dwarf will remain patient and unchanging, drifting slowly through the galaxy. This stage of the sun's life is not an end, but a transformation. The matter that formed the white dwarf is the same matter that once formed the core of the sun, the same matter that gave warmth to the earth and light to every planet. It continues to exist, only in another state, condensed, quiet, and pure. The energy that once filled the solar system now moves through space, dispersed and even part of the wider balance of the universe. The white dwarf will travel with the Milky Way as it turns through time. Around it, other stars will be born and die, and new systems will take shape from the same dust that once surrounded the sun. The quiet birth of the white dwarf marks not a conclusion, but a return to the stillness that preceded light, a return to the patient rhythm that guides every process in the cosmos. In this stillness, there is no movement that can be heard, no light that can blind, no sound that can disturb. There is only the continued unfolding of nature's laws, repeating their patterns with infinite care. The white dwarf will remain as a faint record of the sun's long life, a final expression of balance between what was and what will come. Its glow will fade gently, so slowly that no single moment will mark its dimming. It will simply become quieter, colder, and smaller, until one day, far beyond counting, it no longer shines at all. When that time comes, the sun will have completed its journey. Its energy will have been shared, scattered, and returned to the universe. The white dwarf, once a symbol of what remains, will cool into darkness, becoming a silent point in the endless fabric of space. This is the quiet birth of the remnant, the sun's last shape, its final breath, and its slow descent into perfect stillness, cooling into darkness. The cooling into darkness will begin when even the faint light of the white dwarf starts to fade. There will be no clear moment when brightness turns to shadow, no visible boundary between warmth and cold. The process will continue through time so vast that the mind cannot hold it. The glow of the white dwarf will grow weaker by fractions too small to measure, and yet they will continue one after another through trillions of years. Slowly, the last energy will move outward until what remains is no longer a shining star, but a cold, dense object, suspended in silence. The white dwarf will become a black dwarf, though no eye will ever see it, for it will give no light. It will be as invisible as thought, existing only as gravity, shape, and memory. The atoms within it will have settled into a perfect stillness, each one in its place, each one without motion. The heat that once sustained its glow will be gone. No radiation will leave its surface. The matter will remain, but the energy will have spread across space, joining the thin background warmth of the universe. In this deep future, the Milky Way itself will have changed. Stars will have burned out, one by one. The galaxy will have stretched and thinned, its spiral arms barely visible. The remaining stars will be red and dim, glowing faintly in the great dark. Planets will continue to orbit them, though their surfaces will be frozen and lifeless. The distances between these systems will grow larger as the universe expands. Space will become wider, colder, and quieter. The black dwarf will continue to move through that space, orbiting the center of the galaxy in slow motion. Its path will be smooth, stable, and unchanged. It will not collide or decay, it will simply drift, unseen. Its gravity will still hold what remains of the solar system, the faint outlines of frozen worlds and the scattered fragments of comets that no longer shine. The black dwarf will no longer influence them with light, only with the invisible weight of its presence. In this distant age, the universe will have grown old. The temperature of space will be near absolute zero, so low that motion itself will almost stop. The background glow of the cosmos will fade into wavelengths too long to detect. Time will stretch without measure, and even the movement of galaxies will slow. The universe will not end in a single instant. It will continue to expand, carrying its fragments farther apart, until even gravity begins to lose its strength. The black dwarf will cool further, though so slowly that each step toward darkness will take longer than all of human history combined. Inside it, the matter will remain solid, crystalline, and still. The sun, once a sphere of fire, will now be a diamond of frozen atoms resting in infinite space. It will be colder than any ice, harder than any stone, and quieter than any silence. It will not shine, yet it will endure, not gone, only transformed beyond light and heat. Around it, time will continue to unfold. New stars will still be born in distant regions of the universe, though fewer and fewer with each passing age. The elements that once came from the sun, hydrogen, helium, carbon, oxygen, will be part of other worlds. In some far place, new planets will form, perhaps with new oceans, new skies, and new life. The matter that once warmed the Earth will take part in those new beginnings. The black dwarf will not witness them, yet its existence will have made them possible. Every particle that once radiated from the sun will have contributed to the shaping of the cosmos. Energy is never lost. It only changes form, moving from one pattern to another. The light that once filled the sky will now exist everywhere, dispersed through time, through dust, through atoms drifting in the dark. The universe, even in its deepest quiet, will still hold the memory of light. It will remain in the temperature of space, in the faint echo of radiation, in the steady pull of gravity that keeps structure alive. The black dwarf, invisible and still, will be part of that memory, a trace of the star that once gave life, a remnant of warmth now turned to rest. This cooling into darkness is not destruction. It is balance. The energy that once burned has now reached its final calm. The universe itself, as it expands and cools, moves toward the same state. Heat becomes evenness, motion becomes stillness, sound becomes silence. The black dwarf is not the end of the sun's life, but the completion of its long return to equilibrium, a final breath stretched across eternity that joins the quiet rhythm of the cosmos, the eternal rhythm of the cosmos. The eternal rhythm of the cosmos continues without interruption. It does not pause to recognize beginnings or endings, for in its vast expanse, every conclusion is the start of something else. The death of the sun, the fading of its planets, and the quiet cooling of its remnant are all movements in a single unbroken sequence, the continuous exchange between energy and stillness, between creation and rest. This rhythm has existed since the first light appeared and will persist long after the last star grows dark. Every star follows this pattern. Some live short and bright, burning their fuel in only a few million years. Others, like the sun, endure for billions, their lives measured by the slow balance of fusion and gravity. When they reach their ends, they leave behind white dwarfs, neutron stars, or black holes, forms of matter transformed by time. Around them, new stars are born from the clouds of gas and dust left behind. This cycle is constant. Each death returns material to the galaxy, and each rebirth begins again from what came before. Nothing is lost, only changed. The galaxies themselves participate in this rhythm. They move through space, drawn together by gravity, colliding and merging with others. These encounters reshape their structure, blending their stars into new formations. The Milky Way, too, will one day join with another galaxy, forming a new and larger one. The process will take billions of years, and through it stars will shift into new orbits, carrying their planets and remnants along with them. Even the black dwarf that once was the sun will take part in that slow dance, moving with the current of gravity through the expanding universe. As ages pass, the cosmos becomes quieter. Fewer new stars will ignite. The gas that once condensed into suns will become scarce, spread thin across the vastness of space. Light will travel farther without meeting matter. Galaxies will drift apart, and distances will grow beyond what any signal can cross. Yet even then, the rhythm continues. The universe, expanding and cooling, is still a field of interaction, where gravity, radiation, and time move together in perfect order. In this distant future, there will be no boundaries between day and night, no warmth to measure, no motion to feel. But the laws that guide all things will remain. Energy will persist, distributed evenly across infinity. The quiet that fills the universe will not be absence but completion. It will be the balance reached after every transformation has slowed, after every vibration has ceased, after all light has diffused into the same constant tone. The sun's story is one expression of this greater pattern. It was born from the remains of older stars. It lived by transforming matter into energy, sharing its light across the solar system. It gave warmth to planets, energy to oceans, and stability to the delicate rhythms of life. When its time ended, it returned that energy to the universe, spreading it outward to become part of everything again. That process is still continuing. It will never stop. To imagine this rhythm is to look beyond moments and beyond lifetimes. It is to see the universe not as a sequence of events, but as a continuous field of change. Each atom within every star, planet, and living being participates in it. The air once breathed on Earth may one day drift through another world. The dust that now floats between stars may one day form the surface of a new planet. The rhythm is everywhere, repeating in forms large and small, infinite and familiar. In the end, when all stars have cooled and all motion has slowed, the universe will still exist in quiet balance. It will no longer shine, but it will still be. Matter will remain, energy will remain, and time will continue its endless unfolding. The silence that fills it will not be void, but peace. The natural stillness that follows after all motion has found its place. This is the eternal rhythm of the cosmos, the slow breathing of creation, expansion, and rest. It is the pulse that has guided the sun and every star before it. It is the same rhythm that flows through the smallest atom and the largest galaxy. It is patient, infinite, and calm. The story of the sun is part of that rhythm, one note in the endless harmony of time. And as its light fades, the rhythm continues, unchanged, moving softly forward through the quiet of eternity. The soundless universe, exploring why space is silent. The soundless universe will continue to expand through time without boundary or limit, spreading energy so thin that motion itself will one day lose its meaning. In this future, space will be almost empty, its particles so distant from one another that collisions will no longer occur. The silence that exists now between stars will deepen until it becomes complete. No sound will travel, for sound requires a medium, air, water, or gas, and in the emptiness of space there will be none. The universe will be filled with vibrationless quiet, a stillness that cannot be heard but can only be understood. Even today, the silence of the cosmos is absolute. The explosions of supernovas, the flares of stars, and the collisions of black holes make no sound as they happen. They release energy, light, and radiation, but not vibration. Space does not carry the trembling of matter, only the movement of light. What we call the noise of the universe is only data, signals that our instruments translate into sound. In truth, the cosmos has always been mute. Every star has lived and died in silence. Every planet has moved in silence. Every comet has crossed its orbit without a whisper. If one could drift through space near the place where the sun once shone, there would be no sound of its fading, no echo of its light disappearing. The black dwarf that remains will be silent in every way, radiating no energy, creating no waves, disturbing nothing. It will be a perfect expression of quiet, matter at rest, temperature balanced, gravity unchanging. Even time itself, though continuing, will seem slower there, as if stretched by the vast emptiness surrounding it. In the soundless universe, events still occur, but their passing cannot be heard or felt. Atoms move, but their motion is too slight to be sensed. Radiation travels, but its frequency is too low to be detected. Galaxies drift apart, but their separation is silent, without friction or resistance. The only record of these movements is the changing shape of space itself, which bends gently under the weight of matter and energy. This bending is also soundless, a motion without pressure, a wave without noise. Long after the sun and all stars have cooled, the universe will still hold these faint, invisible movements. Space will continue to stretch, carrying with it the last traces of radiation. The background temperature will fall toward absolute zero, yet never quite reach it. Even at that limit, there will remain a faint hum of energy. not as sound but as existence. It will be the quiet breath of the cosmos, the minimum vibration that defines being. This silence is not emptiness. It is the natural condition of space when it is undisturbed. Within it there is still structure, still matter, still law. The silence allows the universe to endure without wear, to exist without friction, to move without decay. Every star that has ever shone, every planet that has ever formed, has done so within this silent field. Sound belongs to air, to wind, to worlds where matter presses against matter. The universe itself has no such boundaries. It holds all things, but it vibrates for none. If one could listen to the universe, one would hear nothing at all, not because there is no movement, but because movement here does not make sound. The quiet is total. The black dwarf of the sun will continue to move in its orbit, circling the center of the Milky Way. But the sound of that motion will not exist. The planets that remain will drift slowly, their frozen orbits unbroken, their silence complete. In this stillness, the memory of sound becomes unnecessary. There will be no voices, no winds, no impacts. The universe will exist beyond the reach of hearing. It will not be lonely, only balanced. Every motion will continue as a whisperless expression of law, precise and unchanging. The quiet will not be absence, but equilibrium. The soundless universe will remain this way for as long as time exists. Even as galaxies separate beyond sight, even as space grows colder, even as matter decays into its smallest parts, the silence will hold. It will not stop. It will not fade. It will persist as the final perfect form of peace, the endless stillness that follows all creation. And in that stillness, the sun's journey will be complete, its last traces dissolved into the quiet fabric of the cosmos, joining the rhythm that continues forever, unheard and undisturbed. The last photon. What happens when light itself stops traveling? The last photon will begin its journey when the universe has already grown vast beyond measure. By this time, the stars will have cooled into black dwarfs, the galaxies will have faded into invisibility, and the expansion of space will have stretched all wavelengths of light into distances longer than comprehension. The few remaining photons, particles of light that once carried the warmth of stars, will still move through the darkness, but their energy will be faint, diluted by time. Each one will travel endlessly, slower only in perception, their existence stretched across expanding space. A photon never stops. It does not rest or fade in motion. It continues to move at the same speed through any era, through any distance. But as the universe expands, its wavelength lengthens and its energy becomes weaker. What was once a ray of visible light becomes infrared, then microwave, then radio, until finally its frequency is so low that it no longer interacts with matter. These are the last photons, the final light of the universe, traveling through an environment that grows colder and quieter with every passing age. The energy of these photons comes from the history of everything that has ever been. The warmth of stars, the glow of galaxies, the radiation from the birth of the cosmos, all of it still exists in the form of light. The cosmic background that scientists can observe today is the ancient afterglow of that creation, a faint reminder of a time when everything was bright. Over billions of years, that light has dimmed and cooled, stretching into microwaves, then into longer waves, and one day it will stretch beyond detection entirely. In the far future, When all other sources of light have gone dark, the universe will still be filled with these last photons. They will be everywhere, uniform and quiet, moving through space without touching anything. There will be no stars left to absorb them, no atoms to scatter them, no eyes to see them. They will pass through the void unimpeded, spreading thinner and thinner as space itself continues to grow. Their paths will be endless, their presence eternal. Each photon will carry within it a trace of the universe's history, the record of energy released by the first stars, by the collisions of galaxies, by the fading of the sun. They will not remember in the way that minds do, but their frequencies will hold information, the signature of everything that came before. In that way, light will remain the final witness of creation. Though it will no longer illuminate anything, it will still define the fabric of space, the quiet imprint of a time when the universe was full of motion and heat. As the expansion continues, these photons will stretch beyond usefulness. Their wavelengths will become so long that their energy will approach zero. They will move without resistance, but without interaction. Their presence will no longer be distinguishable from the background of existence. The universe will become a field of uniform energy, not bright, not dark, not moving, simply balanced. This is the quiet end of light, the slow dissolution of energy into stillness. The last photon will not stop. It cannot be captured or destroyed. It will travel forever, even when forever no longer has meaning. There will be no edge for it to reach, no surface to strike. It will exist as motion without destination. And in that endless journey, it will mirror the history of the universe itself, a constant flow that began with brightness and ended in equilibrium. In this final stage, the universe will no longer change in any measurable way. There will be no stars to form, no galaxies to merge, no heat to transfer. Everything that could happen will already have happened. The photons that remain will drift in perfect uniformity, their waves stretched across unimaginable distances, their energy too faint to disturb even the smallest particle. This is not a tragedy, nor is it loss. It is the completion of a cycle. The light that once filled the skies will have fulfilled its purpose, carrying energy from creation to calm. The last photon will represent the last trace of motion, the last expression of time. When its wavelength becomes infinite, the universe will have reached complete equilibrium. The same quiet balance that existed before the first light appeared. In this final silence, there will be no distinction between light and dark, between movement and stillness. The last photon will not vanish. It will simply become part of the infinite, constant field that remains. The universe will have returned to its purest state, calm, balanced, and eternal. The rhythm that began with the birth of light will continue, not through motion, but through the quiet existence of everything that remains, unchanging and whole. The cooling of time. How entropy slows motion everywhere. The cooling of time will be the final and most gradual transformation of all. It will not arrive suddenly or be marked by any visible sign. It will happen quietly as the universe stretches farther and farther, until motion itself seems to lose purpose. What began as heat and expansion will reach a state so even, so balanced, that the concept of before and after will start to dissolve. The flow of time, which once carried energy from one moment to the next, will slow as temperature and motion approach equilibrium. The universe will not stop. It will simply grow still. In physics, time is tied to change. to energy moving from one form to another, to entropy increasing as systems evolve. When there is no more change, time becomes undefined, not because it ends, but because there is nothing left to measure its passage. In the far future, when all energy is evenly distributed, the cooling of time will begin. Every process that once defined difference, the burning of stars, the rotation of planets, the movement of light, will have faded. The universe will exist, but without rhythm. Temperature will be uniform everywhere. The faint background radiation that once filled space will have stretched until it is indistinguishable from emptiness. The difference between hot and cold, between full and empty, between motion and stillness will disappear. The laws of thermodynamics will remain, but there will be nothing left for them to act upon. The cosmos will reach its final condition: maximum entropy, complete balance, perfect calm. To understand this cooling is to imagine stillness as a form of continuation rather than an end. Each atom, each particle will remain in place, moving only through the faintest quantum fluctuations. These movements will be so small that they will not transfer energy or create change. They will exist only as the minimal expression of existence itself, motion that has no purpose but must persist because nothing can be completely without motion. Time in such a universe will stretch infinitely. Seconds, minutes, and ages will blend into one continuous duration without event. The cooling of time is not decay, but completion. Everything that could happen will have already occurred. Stars will have formed and died. Galaxies will have collided and scattered. Light will have traveled every possible distance. The universe will not be dark in the way of absence. It will be evenly filled with faint energy, soft and unchanging. In this state, time itself will lose distinction, for there will be no process to divide one moment from another. If there were still observers, they would find no sunrise or sunset, no shifting of stars, no aging of anything. Every place would look the same as every other. Each particle would experience existence without duration, a steady persistence without transformation. The arrow of time, the direction from past to future, would fade, for the universe would no longer contain contrast between what was and what is. Entropy would have reached its ultimate form, silence. Yet even this silence carries meaning. It shows that the universe obeys its own order perfectly, that every exchange of energy has found its balance. The cooling of time is the natural consequence of expansion, of the long journey from the first burst of creation to the last whisper of radiation. Nothing has been wasted. The energy that once made stars shine now fills space evenly, distributed across infinite distance. The light that once illuminated worlds now rests, stretched beyond perception, part of the uniform calm of all that exists. In this final condition, time no longer measures change. It becomes identical with space, an unbroken continuum, neither moving nor pausing. The difference between near and far, between before and after, becomes meaningless. The cosmos becomes a single, complete entity, existing not in motion, but in being. Its silence is not the silence of death, but of fulfillment. If one could imagine standing within it, one would not feel cold or dark. There would be no sense of distance, no sense of self. There would only be equilibrium, matter and energy in their simplest, most stable form. The universe would have reached the point where every potential has been realized, every difference dissolved. The cooling of time is the last stage of order, the final alignment of all processes toward peace. It is the long exhalation after the bright expansion of creation. What remains will not fade or vanish, it will endure in quiet permanence, timeless and whole. Time will not end. It will become still, a vast motionless ocean that holds everything it ever was, unchanged forever.